Ionic equations and net ionic equations are a mystery for many students. I'm hoping that this short presentation will help clear things up for you. First of all, you have to know that when you're writing either complete or net ionic equations, that all liquids, all solids are not going to show, they absolutely will not show as ions in the complete or the net ionic equation. Now, as you go down here, you're going to see just a regular complete equation. And let's fix this. Just wanted to get that one in there. But at any rate, this is your balanced complete equation. Okay, next we go to an ionic equation. Now, when we write ionic equations, complete ionic equations especially, we're writing everything as ions instead of compounds like you see here in the balanced equation. So, if you notice that this 3 subscript becomes a coefficient when we write the hydrogen ion, and that the phosphate, because the coefficient is 1, and this 4 only refers to the oxygen in the phosphate, there's only going to be 1 of the phosphates and when we write them as an ion. And the rubidium, of course, is going to be written as 3 rubidiums because of the coefficient. The hydroxide will be written as 3 hydroxides, again because of the coefficient. And then 3 for the waters, and you'll notice waters as liquid refer back to here. They're not going to show as an ion because it's a liquid. The rubidium ion over here, there's 3 of them because of the subscript here, and then there's 1 phosphate because of the coefficient. And that gives you your complete ionic equation. Now let's see where everything came from. You'll notice here, the hydrogen became the hydrogen ion, the phosphate became the phosphate ion, the rubidium here became the rubidium ion, and the hydroxide here became the hydroxide ion. Likewise, or over here, quite differently, the water stays as water because it is a liquid. You'll have this same situation when you deal with solids. So let's look again here and let's find the rubidium, where that's going. Okay, let's fix that just a minute. Okay, now we have the rubidium going where it's supposed to go, and finally the phosphate winds up over here. Now I'm going to move this back so we see this as the complete ionic equation. Now let's go on down and let's look at the beginning, or let's look at the beginning of what's going to wind up being our net ionic equation. So for the net ionic equation, we're again going to take our hydrogen and move that down just as it is, 3 hydrogen ions. We're going to take the hydroxide ion and move that down, and of course there's 3 hydroxides. But you're going to say, well, what about the phosphate here? Okay, this little guy, phosphate, we're leaving him out. Correct. What about the rubidium? We're leaving him out. Absolutely. And so on the left side of the equation, all we have now is what we call the ions that are doing the business, so to speak, of making water. See, the phosphate doesn't get involved. It's just not. And the rubidium doesn't get involved. So essentially we're crossing them out, okay, because they're not going to be in the net ionic equation. And notice the water isn't going to change at all, okay, it's just water because it was liquid. And this rubidium and this phosphate are going to go away. So in our net ionic equation, this is what we have, but like any other balanced equation, we're going to have to reduce it to its lowest possible terms. And so that's why in the final net ionic equation, or the final version of it, we're going to have hydroxide ion plus hydrogen ion plus hydroxide ion come together to form water. And that's all there is to ionic, whether they're complete or net, are going to be in ion form, except for liquids and solids, which is what's going to show up always on the right side. And the aqueous stuff stays aqueous, and so we write it as aqueous because that's how it's going to be in the water. So I hope that's going to help you and make this make sense for you.